Very good afternoon to all. Okay, I welcome you all for this today's lecture of our subject, that is industrial hydraulics and pneumatic. Okay, so in last lecture, that is in the last Tuesday, we have started our main topic, that is hydraulic actuator. Okay, and after that lecture, 4 days there was no lecture happened for our subject. So quickly I will take the a revision or a recap on the points that is covered in the last lecture. That is, what is meant by hydraulic actuator, and then we'll go for this classification, and then we'll go for the linear actuator. Hello. Hello. Whether my voice is audible at your end?
Yes.
Whether my voice is audible, just tell me. Unmute yourself. Anybody. Anyone can just. Ruturaj Kai, whether my voice is audible? Ajit Gaikwad.
Yes, sir, audible.
Yes, sir. Okay.
Yes, sir, audible.
Okay. So I will start with the introduction and the classification of hydraulic actuator. This point already we have discussed in the last lecture, but just a revision purpose, I will start with the introduction of the hydraulic actuator. Okay, as we know that hydraulic actuators are the main or the important element of hydraulic system, and the main function of hydraulic actuator is that to transmit or the transfer the hydraulic energy, that is fluid energy, into the useful work. Please remember, hydraulic energy is going to convert into the useful work, that is mechanical work. Getting it? That is the main function. Okay, and there are many applications of this hydraulics. So in hydraulics, the main applications of the hydraulic actuator is concerned with your moving, gripping, lifting, and rotating motion. Okay, with force. So for that application purpose, hydraulic actuators are used. Okay, so again I can simplify in simple words. I can tell that devices that actually actuate this motion or this objective are called the actuators. Okay, hydraulic energy, with the help of hydraulic energy, some useful work or the mechanical work can be done. So that device is known as or is called as hydraulic actuator. Getting it? Now, depending upon the motion that produced or that transmit at the end of the actuator, okay, based on the motion which produced by the actuator, depend on that, the actuators are classified as first is the your linear actuator, and the second subgroup is called rotary actuator. Okay, once again I am repeating, depending upon the motion actuator transmit, no, so depend on that motion, actuators are classified as into the two subgroup. That is, one is the linear actuator and second is the rotary actuator. Now for linear actuator, it converts hydraulic energy into straight line motion. In simple words, I can tell linear actuators convert hydraulic energy into straight line motion. Please remember. Okay, linear actuators convert hydraulic energy into straight line energy. Okay, and also these linear actuators also called as hydraulic cylinder. Please remember this word. Linear actuator means your hydraulic cylinder. Getting it? And these linear actuators, they include various types of hydraulic cylinder. Okay, linear actuators also known as hydraulic cylinder, and they include various types of the hydraulic cylinder. Now, which are the different hydraulic cylinders under this linear actuator? That we should know. So for that purpose here, I have written the classification. That is, you can see the first subgroup of the linear actuator of the hydraulic cylinder is the single acting cylinder. Yes, single acting cylinder. Okay, this is a hydraulic cylinder, type of hydraulic cylinder. Okay, belongs to the linear actuator category. Then double acting cylinder, and along with these two, single acting and double acting, we have another category of the linear actuator, that is a special cylinder. In that, here I have written telescopic cylinder also. This is a special cylinder. Okay, telescopic cylinder. So these are the linear actuators, or we can call hydraulic cylinders. Okay. Now another group of the hydraulic actuator is the rotary actuator. Okay, so this rotary actuator convert your hydraulic energy into rotational motion. Okay, hydraulic actuators convert the hydraulic energy into rotational motion. Okay, so they may further divided as a limited rotational actuators and the hydraulic motors. Okay, these hydraulic actuators are classified again, okay, into the subgroup, that is hydraulic motors. Okay, in the hydraulic motors we have the gear motor, vane motor, then axial piston motor. Okay, so these are the subtypes of the rotary actuators. Rotary actuators also known as hydraulic motors. Please remember. Okay, hydraulic motors means the rotary actuators. Okay, in the hydraulic actuator group. Getting it? And that third subtype, that is axial piston motor. Again, it is divided into the two types. One is the swash plate axial piston motor, and second is the bend axis piston motor. For each and every category or every subgroup of this type of the actuators, we are going to see its working principle, construction. Okay, and it's a symbol. Okay, one by one, that also we are going to check. Okay, now this rotary actuators, they divided into the divided as a limited rotational actuator. Okay, if you will get the oscillating motion, then that also belongs to this category. Okay, and this hydraulic motors. Getting it? And this limited rotary or rotational actuators means what? They transmit the part of full rotation. Okay, part of full rotation. Okay, and whereas your hydraulic motors, what they are doing? Hydraulic motors are hydraulic equivalent of your electrical motor. Okay, hydraulic motors are the hydraulic equivalent of your electrical motor. Okay, which may be your unidirectional or the bidirectional. Okay, that type also we are going to see. Getting it? Now, the first point about the hydraulic actuator that we will see, that is the linear actuator. Linear actuator. Okay, please remember, linear actuator means what? Hydraulic cylinder. Linear actuator means hydraulic cylinder. Okay, and this hydraulic cylinder is the most widely used actuators of the hydraulic system. Please remember, these hydraulic actuators means hydraulic cylinder, linear actuator. Linear actuator you can call out the hydraulic cylinder. Both are the same. So this hydraulic cylinder is the most widely used actuator of a hydraulic system. Okay, and this hydraulic cylinder transform the flow of your pressurized fluid into the push or pull of your piston rod. Okay, that means please just look at on the slide. What I have written: hydraulic cylinder transforms the flow of pressurized fluid. Means what? Hydraulic energy. Okay, flow of pressurized fluid into a push or pull of piston rod. That means that work or mechanical work you can call. Hydraulic energy is converted into the mechanical useful work. Okay, that means the pull or pushing of your piston rod. Getting it? So that is hydraulic cylinder's main function. Okay, to transform flow of pressurized fluid into push or pull of piston rod. Please remember. So since these hydraulic actuators, they transmit the linear motion. Okay, so due to that only, they are also known as linear motors. Okay, please remember, linear actuators or hydraulic cylinders or linear motors. These three means the all are same. Getting it? As they transmit the linear motion. Okay, flow of pressurized fluid is going to transfer into the linear motion. Okay, so due to that transmission of linear motion, they are also known as linear motors. Okay, so the linear motion, whatever obtained from the hydraulic cylinder, that can be used. Okay, that can be used. Once again, I am repeating: the linear motion which is obtained from the hydraulic cylinder can be used to pull, to push, or to lift, to grab, to turn, or any other useful form of the work. Okay, with the use of another separate links and the mechanism. Okay, getting it? So what are that? To pulling or to pushing, to lift, to grab, to turning. So these are the other useful form of work. Okay, that can be done with the help of links and the mechanism. Okay, so that is called the linear motion. Getting it? Now here, whether concept of linear actuator clear, everyone? Did you got the meaning of linear actuator, linear motor, or the hydraulic cylinder? What is the function of this? Getting or not? Just tell me. In chat box, just tell me yes or no. Do you got the meaning of linear actuator or hydraulic cylinder? Please tell me. Just unmute yourself, or you can write message in the chat so that I can move further. Understood or not? Linear actuator. Okay, just I will take the review of whether it is clear or not. I will ask to one student. Just tell. 1 minute. Rahul Khadke, please tell me what is my linear actuator or hydraulic cylinder? Sambhaji Patil, Rahul Khadke, anyone? Rahul Khadke, unmute yourself and just tell me what is function of linear actuator. Nikita Pawar, unmute kara please. अनम्यूट करून सांगा ना प्लीज प्लीज. तुम्हाला समजतंय की नाही मला कळून जाईल ना. Otherwise just I am explaining. Okay, whether it is grabbed by you or not. Okay, it's a confirmation I need. If you got point, then I can go further. Nikita Pawar, unmute yourself and just tell me what is the function of linear actuator or what is mean by linear actuator or hydraulic cylinder? Just tell me. One
Sir,
line answer. Bola, please go ahead. Nikita, please go ahead.
sir, it can transfer the flow in pressurized manner.
Flow of pressurized fluid is going to transfer into what? कशात कन्वर्ट होणार हो? फ्लो ऑफ प्रेशराइज्ड फ्लुइड म्हणजे काय? ते हायड्रोलिक एनर्जी ते कशात कन्वर्ट करणार आहे ऍक्च्युएटर?
Mechanical energy.
इनटू
Mechanical energy.
मेकॅनिकल एनर्जी. नाउ मेकॅनिकल एनर्जी मीन्स व्हॉट? सम काइंड ऑफ वर्क. बरोबर? मग ते सम काइंड ऑफ युजफुल वर्क म्हणजे काय असणार हो? पुलिंग, पुशिंग, टर्निंग or grasping of any job. Getting it? So whatever I am giving the example, pushing, pulling of the piston, grasping of any body, any product or any part. So that is called the linear motion, no? So due to that only it is called the linear motor also. Getting it? Understood or not? Power, Nikita, power.
Yes, sir.
Okay. Next, one more. I will ask to Prathamesh Patil. Prathamesh Patil. Prathamesh Patil. Just to tell me whether linear actuator, hydraulic cylinder, and linear motor हे सगळं सेमच आहेत का वेगवेगळं आहेत? प्रथमेश पाटील, शुभम गांडुळे, ऋषिकेश देशमुख, गौरव कारंडे, गौरव कारंडे, गौरव कारंडे, सोनटक्के, roll number 44. Just to tell me the whether linear actuator, hydraulic cylinder, linear motor, whether these three are same or different. Pramod Avlekar, Pramod, please unmute yourself and just tell me yes or no. Hello, Pramod. Same. Okay, chalo. Okay, so Saurav has given answer, no problem. Chalo. Now we'll go for the next one. Okay. So we have seen the classification. Actually, beta. Okay. Now, one small question arises that how to designate the hydraulic cylinder in the industries. Okay, because every product has its designation. Okay, getting it? It's some symbolic representation or the some statistic oriented designations are there for every product in the industry. So these hydraulic cylinders are designed and manufactured for varieties of the services. Correct? Because every cylinder or in any application, the function is same, but that hydraulic cylinders are designed based on the application. So these hydraulic cylinders are designed and manufactured for a variety of services, but their size is designated as one standard is designation is used for their representation. So how to present this hydraulic cylinder, or how to designate this hydraulic cylinder, that we should know. Okay. So in industry, all the cylinders, okay, are designated by this standard. Okay. I have mentioned in the slide. You can see 84 by 48. Okay. This dash 500. Okay. So this is a designation of the hydraulic cylinder. Now, the another question arises is that what is meant by that 84? Okay. Then 48, and then 500. Okay. In industry person will tell like that hydraulic cylinder. Okay. It's a designation like 85 by 48. Okay. Dash 500. Okay. So we should know what does it mean that. So 85 means what? That is the diameter of your piston. Okay. Hydraulic cylinder, in that piston is there. So the diameter of the piston means that 85. 85 indicates, okay, this 85 number indicates the diameter of piston. Please remember, this is a practical oriented knowledge. Yeah? We should know this. Then for what is that 48 number? So 48 number indicates the diameter of the piston rod. Diameter of the piston rod. And what is that 500? 500 means your stroke length. Okay, stroke length. Getting it? So please write this. Okay, this designation of the hydraulic cylinder. Designation of the hydraulic cylinder. This question may ask in the university exam. Okay, as a MCQ. 85 by 48 dash 500. So we should know what is mean by first number, the second and third. First number indicates that diameter of the piston. Second number indicates that diameter of the piston rod. And third number indicates that stroke length. So by these three numbers, hydraulic cylinder designated. Getting it? Because in industry, varieties of the for variety of services, cylinders are designed and manufactured. But their sizes, what are the size of the cylinders are there now? So that are designated by this standard only. 85 oblique or 85 by 48. Okay, what is that number that I have taken as a sample? Okay, that may be your 90 by 45 minus 600. But that 90 means what, or the 85 means what? Diameter of the piston. And what are the 45 or 48 is there? No? That number indicates the diameter of the piston rod. And the remaining third number, 500 or 600, that is your stroke length. Getting it? So please write on this. Okay, I will give 1 minute to write this. Designation of the hydraulic cylinder. Hurry up.
Over. Over. Now let us go for main point. Okay. Whether this slide is, I think, visible. So now main point, that is a, now we come to know that hydraulic cylinder means what, but we should know the basic construction and the operation of the hydraulic cylinder. Okay, basic construction and the operation of the hydraulic cylinder. Okay, so this figure, okay, this indicates or the illustrate that basic construction of a hydraulic cylinder. Okay, through this figure, okay, now I am going to explain the basic construction of the hydraulic cylinder. Okay, now further we are going to see the types of the cylinder, but through this figure you will get the basic construction and the operation of the hydraulic cylinder. Okay, so basically these hydraulic cylinders it consists of a cylinder tube. Okay, it consists of a cylinder tube which is fitted with the close fitting piston. You can see where is the piston tube. You can see, okay, pistons tube. Okay, just look at my mouse, okay, on the screen. This is a piston tube. Once again, I am repeating, this hydraulic cylinder basically it consists of a cylinder tube which is fitted with a close fitting piston. Where is piston? See, this is a piston. Getting it? Attached with the this piston rod. Piston rod. Cylinder tube fitted with a close fitting piston. Getting it? Then it is attached with a piston rod at one end only. Okay, piston rod, it is attached with this piston. Getting it? And both sides of the cylinders, okay, both the sides of the cylinders are closed with the cylinder head and cap. Okay, both the sides of the cylinder are closed with the cylinder head and cap. You can see cylinder head. Okay, this, and that is cylinder base you can call, and this is a cylinder cap. Okay, at both the side you will have the cylinder head and the cap. Okay, so that is both the side of cylinder are closed with this one side. You will get a hydraulic, sorry, cylinder head, that is base, and this hydraulic cylinder cap. Getting it? And the cylinder head and this cap, cylinder head and this cap have ports for connecting to piping. Okay, cylinder head and cylinder cap have the port. Okay, have the ports for what purpose? For connecting to the piping. So you can see at cylinder base or that side of the cylinder base, you have the one port which is connected to the piping. You can take fluid in or you can exit the fluid out from this port. Like way here also we have the port which can be connected to the piping. You can see, okay, the red side and this bluish. Okay, this, what are the arrows shown? No, that is a port. Okay, so both the sides of the cylinder, okay, at the cylinder head and the cylinder cap have the ports which is for what purpose? For connecting to the piping. Okay, through that you can take fluid in or you can take out also. Okay, so due to that only arrow having the bidirectional, that means the both direction you can take out fluid. For that purpose both direction it is shown. Okay, then what are the piston is there? No, so it has the seals. Piston, you can see this is piston. Please check, look at my on screen and at my mouse. Okay, so this piston has the seals. Okay, to seal this pressure. Okay, seals kala diste na. So that is a seals. For our purpose it is used. So to seal the pressure and non-pressure side of the cylinder. To seal, to pack that pressure and non-pressure side of the cylinder. And the and this cap end. Okay, this cap end, you can see this cap end. Okay, so this cap end it carries the seals. Okay, this cap end carries the seals, and wiper it is also there over this piston rod. Wiper, piston rod wiper. You can see the black part, okay, on this piston rod. Okay, so that actually it acts as a seals. Okay, you can see the piston seals here. It is used. Then this piston O-ring, that is also sealing part, sealing and packing. Okay, piston O-ring. Okay, that rings, seals and packing. It's a type we are going to see. Okay, that is the last part of this first chapter, seals and packing. But we should know here where that seals are used. Piston seals, you can see piston O-ring. Okay, then piston here, piston rod seals is there here, and piston wiper. Okay, so this piston has a seals, okay, to seal the pressure and non-pressure side of the cylinder, and the cap end carries the seals also. Okay, and wiper is here, okay, over this piston rod. Okay, getting it? So this is the construction of the hydraulic cylinder. Now, small question arises is that how it operate. Getting it? How it operates this hydraulic cylinder. Okay, so what are the working fluid is there? No, so that working fluid which is under pressure, that enters through this cylinder ports. Okay, that enters through this cylinder ports. Okay, ports I have shown, the red part and the blue part. You can see the arrow. Once again, I will tell what are the working fluid. So that is the piston head area or annular area of the cylinder. And this, what are the, after entering this fluid into this area, red area, okay, that fluid, okay, so it have the some pressure. So that what are the fluid pressure is there? No, so that forces this piston against your load, okay, against your load, and due to that it causes the piston and piston rod to move, okay, to move. Okay, when pressurized fluid apply its that fluid pressure or fluid pressure is going to apply the force on this side of the piston. You can see from the red side, you can see. Okay, when it applies the pressure or force to this side, no, then due to that force, your piston and piston rod, it will move against the load. Okay, that means it will come like to this cylinder cap, up to the towards the this cylinder cap. Okay, so thus transmitting the linear motion to the element to which piston rod मराठी असतो. हे आपण लाल साइड बघतो ना, रेड साइड, इथून काय होणार, फ्लुइड आत येणार. फ्लुइड आत आल्यानंतर त्या फ्लुइड काय असणार, प्रेशरायझर फ्लुइड, त्याच्या फोर्स मुळे हे जे पिस्टन हेड दिसतो ना, त्या पिस्टनवर काय होणार, फोर्स अप्लाय होणार. आणि पिस्टनवर फोर्स अप्लाय झाल्यानंतर जी निळी साइड दिसतो ना, त्या साइडला म्हणजे सिलेंडर कॅपच्या साइडला ते तुमचं पिस्टन मूव्ह होणार लिनियर मोशन मध्ये. बरोबर आहे? मूव्ह झाल्यानंतर ओके, ह्या साइड मधून पुन्हा ते पिस्टन सॉरी हे फ्लुइड इथनं बाहेर पडणार आणि हे मूव्ह होणार. ओके, दॅट इज कॉल्ड द लिनियर मोशन. इट दॅट मीन्स प्रेशराइज्ड फ्लुइड. ओके, इट्स अ hydraulic energy is converted into the linear motion. That means the transmitted linear motion. Okay, to this element means what? This piston rod. Okay, it will pull or push. It will move. Getting it? So that is a working of or operation of the hydraulic cylinder. Getting it? This is a 2D diagram of the hydraulic cylinder. Now I request you all of you, please draw this diagram. Basic construction and operation of the hydraulic cylinder. Please draw this diagram. Please draw this diagram. Or before diagram, would you like to see the one video about this hydraulic cylinder? 1 minute. One minute. I will show.
Actuators. So actuators is used in hydraulics and pneumatic system, means in a fluid power systems. So actuators are those component of a fluid power system. Fluid power means it is hydraulic as well as the pneumatic system which produce mechanical work as a output. Means in a actuators we either supply the hydraulic energy or a pneumatic energy, and this hydraulic energy or a pneumatic energy is converted into a mechanical energy. Means basic functions of the actuator is to convert.
Is it okay to have a video? Okay, after each point, just tell me. Is it okay to you all to have a video? Okay, based on each point, just tell me in chat box. Just tell me yes or no. Or may I go for next point? जे आपण ऍक्च्युएटर लगेच ऍक्च्युएटच्या रिलेटेड एखादा अॅनिमेशन व्हिडिओ बघितलं का बरं होईल का? म्हणजे आपल्याला समजायला अजून सोपं होईल. इन चॅट बॉक्स जस्ट टेल मी येस और नो. Because through the 2D diagram, sometimes it is difficult to understand. But if you learn that construction details and if you see immediately one video about that point, then it is very easy to understand that. Is it okay? Just tell me yes or no in the chat box. All of you. Yes, sir. Show animation. Okay. Okay, we'll go for
hydraulic energy into a mechanical energy. Okay, in a hydraulic system we study that the pump is also used and hydraulic motor is also used. Okay, so actuator is also known as the hydraulic motor. Okay, so what is difference between the hydraulic pump and hydraulic motor? In a pump mechanical energy is converted into the hydraulic energy. Okay, so actuator function is opposite to the pump. Okay, in a pump mechanical energy is input, in actuators mechanical energy is the outputs, and in a pump output is the hydraulic energy, in actuators input is the hydraulic energy. Means output of the pump is the hydraulic energy and it is the hydraulic energy is the input of the actuators. Actuator develop force and displacement which is required to perform any specific task. The task may be of any kind, such as to move, to press, to lift and to clap and so on. Means functions of the actuator is different. It is used to move the some components, to press means in a hydraulic press machine it is used, to lift the some components and to clamp and so on. Okay, means actuator is connected with some other components of the mechanical systems or the different types of the hydraulic machines that we understand in a chapter number 1, that is a various applications of the hydraulic systems. Okay, actuator are common for both hydraulic systems and the pneumatic system. Means that is the same type of the actuator is used for hydraulic systems as well as the pneumatic system, but there is a minor changes of this material due to the pressures. Only the difference is hydraulic actuators are made sufficiently stronger to withstand inside pressure of oils and developed a huge amount of the force. So in a hydraulic system we use the compressed oil. Okay, means pressurized oils, not the compressed, but it is a high pressure oil. And when the high pressure is there, then we require the stronger materials to withstand the sufficient pressure, because we know that in a hydraulic system pressure is high compared to the pneumatic systems. Whereas the pneumatic actuators are made lighter using the aluminiums and relatively thin cylinders, as the inside compressed air pressure is just about the 5 bars. Now before moving ahead, I request to like the video and subscribe my channels for watching other subjects. OHP various link is provided means on a top for other subject. Speed of the actuators. Okay, so speed of the actuators is depend on the rate of flow of working fluid. Means speed is depend on the quantity of the working fluid supply. Means speed is depend on the Q, and this Q means rate of flow. So rate of flow of the working fluids can be controlled by using the flow control valves, and flow control valve in short it is known as the FCV. So by using the FCV we are able to control the speed of the actuators. Now how we control the force? So force developed by the cylinder is the product of pressure of working fluid and the piston area. Okay, so force is equal to pressure into the area. So area of this actuator are fixed. We are not going to change this area of the actuators. Okay, so we have only one option to change the pressures. Okay, so for changing the pressures we are required to pressure control valves, and pressure control valve in short written as the PCV. So force of actuator is controlled by controlling the pressure of working fluid using the pressure controls valve. Now how to control the direction? Means in which directions the actuators are rotates or either it is the move. So direction of motion of actuator is controlled by controlling the direction of flow of fluids by using the direction control valve, and directional control valve in short known as the DCV. Means for changing the directions of the actuators we need to use the directional control valves. For controlling the force developed we need to control the pressures, because the force is directly proportional to pressure into area. And if we need to control the speed of the actuators, then we need to use the FCV, means flow control valves. So thank you for watching this video. If you learned something, then like the video and subscribe my channels for watching the more. In this video I explain classifications of actuators by using these various diagrams, so you can
quickly we'll go for the classification.
Actuators are broadly classified in two groups. First is the linear actuators and second one is the rotary actuators. So from the names you can understand what is the meaning of linear actuators and what is the meaning of rotary actuators. Linear actuators produce the linear motion. That's why its name is the linear actuators. And rotary actuator is produce the rotations. So detailed classification is given in the classified charts. Okay, so in the last video I explained what is the actuators. Actuator is convert the hydraulic energy or a pneumatic energy into a mechanical energy. Means input is hydraulic energy or a pneumatic energy and it is converted into the mechanical energy. And this mechanical energy is we require this mechanical energy in a linear motions. Then we need to use the linear actuators. And suppose we require the mechanical energy in a rotation form, then we need to use the rotary actuators. These actuators are classified in two categories, linear and rotary. So first we understand various types of the linear actuators. So in a linear actuators, first one is the rotating cylinder types. Now here you think that these cylinders are rotated, then why we say that it is a linear actuators? Okay, but we know that in a actuators we use the cylinder, piston arrangement, connecting rods. Okay, so in this reciprocating type arrangement, the cylinders are rotated. Okay, and this oil is inside the cylinders. Okay, and they move the pistons, and this reciprocating motions of the piston is converted into this linear motion. That's why it's come in a linear actuators. Second one is the non-rotating cylinders. In a non-rotating there is a two type. First one is the single acting cylinders and second one is the double acting cylinders. Now here you see this image. Okay, this yellow color portion is the cylinder, but it is the cutting portions of the cylinder. That's why we are seeing that here you see this is the piston, this is the piston rods, and this piston rod is connected with the some loads which we need to move, lift or a press, whatever it is applications is required. So what is the meaning of single acting cylinder? Single acting means the oil is only supplied or removed from the one side of the pistons. Okay, means here you see that's the only one part is there and the oil is supplied from this side for the extension, and when the retraction is going on the oil is removed from these portions. Okay, here you see this imaging for the double acting cylinder, means on a both side of this piston oil is supplied and removed. Okay, for the extension oil is supplied from this left side of the pistons, at the same time the oil is removed from this side. So that's why here the extension and arrow in upper direction. When we need to do the retractions, we supplied the oil from these sides, and at the same time oil present on the left side of the piston is removed from these sides. It is called as the retractions. This is the piston rod and this is the end of the piston rod. They are connected with some applications. Third one is the special type cylinders. In a special type, there is a first one is the diaphragm cylinders, second one is the tandem cylinder. Now here you see this is the image of tandem cylinders. Okay, so in a tandem cylinder there is a two piston is used, and this is a piston rods and various four part is there. Okay, this first image is for the extension, second image is for the retractions. Third one is the double rod and cylinder. Double rod and cylinder means on a both the side of the piston there is a rod is there. Okay, in earlier case we here see that only the one side of the piston there is a rod is there. Okay, but both the side of the piston rod is there, then it is called as the double rod and cylinders. And next one is the telescopic cylinders. Now here you see this is the image of telescopic cylinder. Telescopic cylinder means these cylinders are movable inside and outside. Okay, these are the two different images. This is a one type of telescopic cylinders and this is the second types. Here you see these cylinders are inside, but due to this load the cylinders are also move out. You all see these applications of the telescopic cylinders in a various types of the trucks. Okay, for emptying the what amount what is the fill inside these trucks. Okay, so this is called as the telescopic cylinder. So when this container is moving down, the cylinders are moving inside, and when we need to empty the container, we move these telescopic cylinders in a upper directions. And next one is the cylinder with cushionings. Now before moving on to other types, I request to like the video and subscribe my channels for watching. Rotary actuators. So what is the meaning of rotary actuators? At the output we get the rotary motions. So in a rotary actuator, first type is the limited rotation actuators. In limited rotation actuator, first one is the vane types. So here you see this is the vane type actuators. This is the actual diagram and this is only diagram. Okay, this is the actual component. So these are the rotors and these are the various vanes that we already understand in a vane types pump. Okay, that is a vane type pump is there and the vane types actuator is also there. For that I also make the detailed video in a short times, so you can watch it later on. Second one is the piston type. Here you see this is the piston types rotary actuators. In a piston type, that is another two type is there. First one is the rack and pinion type. So here you see this the rack is there and this is the pinion is used. So here pinion gear is mentioned. Okay. And second one is a chain and sprocket type. So instance of rack and pinion mechanisms, they use the chain and sprocket types. Second one is the continuous rotation actuators. So in a continuous rotation actuator, first is based on the direction, means in which direction they are rotated. So first one call is the unidirectional. Unidirectional means the motor is rotated only in a one direction, that is called as the unidirectional. Means suppose the motor is rotated in a clockwise, then they are only rotated in a clockwise direction, they are not able to rotate in anti-clockwise directions. Second one is the bidirectional motors, means bidirectional actuators. Bidirectional means they are rotated in a two direction, clockwise as well as the anti-clockwise, according to which side the fluid is supplied or a oil is supplied. Second one is the based on the constructions. In a base of construction, first one is the gear type rotor. Here you see it is the spur gear or helical gear are used in a hydraulic actuators or a motors. Second one is the vane types. So here you see it is the diagram of the vane type actuators. And the third one is the piston type motors. So in which that is a small 8 to 12 piston is used. So thank you for watching this video. If you learned something,
Every company will be a tech company in the future, and data will be the fuel that powers this revolution.
We'll see how the hydraulic cylinder is.
In this video, we will see the major differences between hydraulic and pneumatic cylinders, their functioning, and their applications in the industrial sector. The common basic component used in these machines that converts fluid pressure to linear actuated motion is the hydraulic cylinder. As diggers on construction sites, assembly lines, but also industrial package machines. Before starting, it is essential to specify that there are differences between single-acting cylinder and the double-acting one. The single-acting cylinder can be ruled in one direction only, and the fluid gas, which is spread by a pump or compressor, enters from one end only and pushes the stem out. To guarantee that it returns to its original position, the single-acting piston is rejected by a spring integrated into the system. The double-acting piston, differently from the single-acting one, can be moved directly by the operator in two directions by sliding it back and forth along its axis. Consequently, there is inclusive control of the mechanical organ. This system is generally the most used for movement of many types of equipment, thanks to the possibility of full control of the same without being subjected to weighting or action of the control spring. Piston assembly shown here is the functional model of a hydraulic cylinder. It consists of a cylindrical bore with an end cap. Its function is to hold the fluid pressure when oil is pumped into the cylinder. A cylinder head is attached to the other end of the barrel. A piston rod extends from inside the cylinder through the head. It transforms the force from the cylinder to the equipment on which the cylinder system is used. A piston is attached to the piston rod. It splits the cylinder bore into two compartments and reciprocates back and forth when the pressure is developed on both sides of the cylinder chamber. A set of circular sealing rings are used in the interface of metals. The seals used between the surface of the metals in relative motion are dynamic seals, and those acting between two surfaces at rest with respect to each other are static seals. A piston seal acts as a pressure barrier between two chambers separated by a piston. The seal is used to wipe dirt from the rod while entering through the head and prevent contamination of oil. A rod guide ring is used to absorb transverse forces acting on the system and prevents metal-to-metal contact of the rod and cylinder head. Now let's understand the operating principle of a hydraulic cylinder. The model shown here is a double-acting hydraulic cylinder. In other words, this means that the system can extend or retract by using hydraulic fluid in both conditions. The hydraulic cylinder functioning is based on the principle of Pascal, given by B. Pascal, a well-known French mathematician who wrote the law of fluid physics in 1653. This law establishes that when an increase in pressure occurs at the point of the confined fluid, this increase is also transmitted to each point of the fluid inside the container with the same intensity. As we can see from the picture, a passage is created in the cylinder to allow the liquid to enter the chamber, which we will name C-A. Since the chamber is airtight, the fluid will exert pressure on all sides. The piston is the only moving part inside the cylinder, so when the pressure rises inside the cylinder, the piston will begin to move. At the same time, it pushes the liquid into the chamber C-B, which, exiting the cylinder, will have lower pressure. Here we can observe the hydraulic cylinder functioning on this digger. The cylinder is attached to the pump through some cables, which contain the hydraulic fluid. A control valve manages the introduction of the liquid into the cylinder chambers. The operator adjusts the pressure exerted by the liquid so that the cylinder piston can perform its linear movement in both directions. The operator can precisely control the digger arm from its position by simply increasing or decreasing the pressure in the cylinder chambers. The pneumatic cylinder is not much different from a hydraulic cylinder. Differently from the hydraulic cylinder, the pneumatic one uses, indeed, a compressed gas instead of liquid. Pneumatic cylinders and actuators are an easy way to gain strength and generate accurate linear and/or rotary movement, and they can be used in harsh environments, even in extreme temperatures. Light and requiring little maintenance, they generally produce less force and a lower speed than hydraulic or electrical systems, but they remain an economically advantageous alternative. The key components of a pneumatic cylinder include end caps, a piston, a rod, a scraping seal, a guide, and sealing gaskets. Pneumatic systems use compressed air to create rotary or linear motion and power applications.
I request you all, please draw this diagram now. I think the concept, the basic construction of the hydraulic cylinder, now you understood. Okay, because we have seen some related videos also, okay, about this hydraulic cylinder. So all of you, please draw this diagram. Be fast. Okay, I will give 3 minutes to draw this diagram because this is a very important diagram. Okay, in the exam, the question may ask like that: explain hydraulic cylinder, basic construction of a hydraulic cylinder with a neat sketch or with a schematic diagram. So that time, if the question will be the 6 marks, then the 3 marks, minimum 3 marks will be for the diagram. Okay. So, and the remaining 50 marks will be for explanation. So, see, importance of the diagram. If your diagram is correct, that means your explanation is correct. But without diagram explanation, is a zero weightage. Okay, it's have zero weightage. So diagram is very important. Whether now you got the construction of hydraulic cylinder, just tell me in the chat box, say yes or no, and simultaneously draw the diagram. In chat box, say yes or no. Only few students are giving a reply. Okay, remaining students, please just say yes, no, yes, no. If you say yes, I can go in the next for the next point. If you know, if you say no, then I can repeat once again, no problem. Hurry up, please draw the diagram, be fast. Okay, then after this diagram, we'll go for the classification of the hydraulic cylinder. And then one by one, we'll go for the single acting, double acting cylinder. Be fast. Okay, as compared to the other division syllabus coverage of this IHP subject, we are lagging of 5 lecture. Okay, I will take some extra lecture now in this week, so that we'll finish this chapter number 1 and we'll go for the chapter number 2. Okay, because I have engaged more lecture for the basics of the fluid power and the hydraulic system. Okay, be fast. Please draw this diagram. And once again, I want to repeat once again that for our subject, for this industrial hydraulics and pneumatic, the 100% syllabus is available in one book, that is hydraulics and pneumatic by Samir Sheikh and Ilyas Khan book. Okay, RK publication. Okay, I will show the you can see on my video also. It's a small book. It contains 100% syllabus of our subject. Okay, I am referring this same book, and it's more than 100 copies are available in our library. Okay, so you can take the hard copy of this book, okay, from our central library. Okay, very small book, but it contains 100% syllabus. Okay, hydraulics and pneumatic by Samir Sheikh and Ilyas Khan. Very nice book. Okay, I am referring this also. What are the diagrams I am showing now? So that diagrams I have taken from this book. Okay, I have scanned it and I have just pasted that diagram in my slides. Okay, so that it is easy to understand you. Hurry up. Take 1 minute more to draw this diagram. whatever pressure fluid is going to come inside that cylinder, no, so that pressure, okay, upon the area of the cylinder is going to apply the force on your that piston, and due to that force only the piston and the piston rod is going to move toward that piston rod wiper end, or you can call it the piston cap end. Okay, that linear momentum or linear motion is going to happen due to the force of force exerted due to that pressurized fluid. Getting it? I think you have drawn this diagram. Let us go for the next point. That is the classification of the hydraulic cylinder. Okay. Now we are going to see the various types of this hydraulic cylinder. Okay. So various designs of the hydraulic cylinder cover such a wide range that would be beyond the scope of applications also. Okay. So we have various types of the hydraulic cylinder. Okay. Now, as per the syllabus, we'll go for this classification. So hydraulic cylinders are classified into the two types. Okay, depending on the whatever the motion getting or producing by that cylinder. Okay, so one is the non-rotating and another is the rotating. Okay, so we have to concentrate on the linear motion, that is the non-rotating. This non-rotating hydraulic cylinder category, it having the again three subtypes. That is the first is the single acting cylinder, hydraulic cylinder, then double acting hydraulic cylinder, and some special designs. The special design hydraulic cylinders are also available. Now, in that single acting cylinder, we have the two types. Single acting hydraulic cylinder having the two types. In that one is a plunger or ram type single acting cylinder. Okay, plunger or ram type single acting cylinder. Okay, again in that two types are available. One is the gravity return based on the retention action happening, no, so that depending on that on which action that plunger or ram is going to retain, no, so again based on that two types are there. One is the gravity return type and second is the spring return type. Okay, that we are going to see one by one. And plunger or ram type, okay, that is the first single acting cylinder, and the second is the single acting cylinder piston rod. Okay, with piston rod. Single acting cylinder. Okay, piston rod cylinder. Okay, single piston rod. Okay, that is the second type of single acting cylinder. Single piston rod, single acting cylinder. Then double acting. In that again, double acting hydraulic cylinder, again two subtypes are there. One is the single piston rod, double acting cylinder, and double piston rod, double acting hydraulic cylinder. See, okay, for each and every we are going to see the construction and its diagram working principle. And in the category of the special design cylinder, we have the four subtypes. In that we are going to see the tandem cylinder, then telescopic cylinder, then nested cylinder, and special design cylinder. So this is the classification of the various types of the cylinder which are in available. Okay. So quickly, please write down within 2 minutes this classification. This is also important. Quickly write down. Hurry up, please write down. Various types of the classification of hydraulic cylinder. Be fast. Okay, quickly you have to write just. Okay, so for every lecture, be with your pen and notebook. Okay, whenever I'm going to ask to write this, that time you have to write. Okay, so after this types of the cylinder, we are going to start with this single acting cylinder. In that, first we are going to see the single acting plunger or ram type cylinder. Okay, single acting plunger or ram type hydraulic cylinder, and then after that we'll go for the single acting single piston rod hydraulic cylinder, and then we'll go for the double acting cylinder, and then we'll go for the special design hydraulic cylinder. Okay, so for each and every we'll go for the construction working, then we'll see some animation video also. Okay, so that you'll get the okay. So let us start with the first one, that is a single acting plunger or ram type cylinder. Single acting plunger or ram type cylinder. Okay, so this a ram or a plunger. Okay, single acting plunger or ram type of cylinder, which is designed to apply force in a one direction only. Okay, this single acting plunger or ram type cylinder, it is designed to apply force in a one direction only. To apply force in a one direction only. Getting it? So the what are the basic constructional difference ram and this ram type cylinder? So the basic constructional difference between this ram and other cylinder is that here ram does not have mostly separate piston. Okay, this ram type cylinder does not have separate piston and cylinder. Okay, you can see in the diagram also. Here separate piston and cylinder it is not available as like in the other one of the in construction diagram we have still seen their piston and the rod of their separate part. But here a ram type or the plunger type cylinder, what of the ram is there now? That will act as your piston. Okay, and ram. So the piston itself is a big and has a uniform diameter. Okay, getting it. And this what are the construction is there also to avoid the that plucking of the piston rod, okay, due to the bending load also. Here ram is a single unit, single. And the common example of this ram type cylinder is your jack cylinder. Okay, we know that jack cylinder. Okay, just we have to do the fluid. Okay, immediately the jack will lift to the load. Okay, so that is jack cylinder is the common example of the ram type cylinder. Okay, and the what are the returning force is there now in this case? Okay, so that will generally is your dead weight or the that ram itself is the retaining force. So you can see here diagram. So whatever the fluid is there now, so that will come inside this cylinder through this non-return wall. Okay, it will come from this whatever the wall is there now. So from that the fluid will enter in this cylinder, then it will apply the force on this ramp, this surface. Okay, so due to that pressurized fluid, it will apply the force on the ramp, and due to that force, ramp will lift in the upward direction. Getting it? In the upward direction. And through this drain, your fluid will exit. Okay, will go outside. Okay, and due to the dead weight or this ram load, okay, weight of this load, no, dead weight of the load ram. So due to that, it will come down. Okay, it will go down like that time. Your whatever the fluid is there, no, inside the cylinder, it will come through this drainage. Getting it? So this is a simple construction and diagram. So this is single acting only. Okay, through only one port you can take your fluid inside. Okay, one port, and you can apply force from one direction only. So due to that only, it is calling a single acting. Okay, single acting. From one side only, you are applying force to the your surface of the plunger, and due to that force which is caused by your pressurized fluid, no. So your ram will lift in upward direction. Okay, and due to the dead weight of the ram, okay, it will come in downward direction. Getting it? And here also you can see the standard ISO symbol for this single acting plunger or ram type cylinder. It is indicated by this one. Okay, you can see cylinder is there, and A means this is the inlet port. Okay, through that you can take fluid inside. This is a ram. So this is a symbol for single acting plunger or ram type cylinder. Getting it? It's a symbol for that. Okay, all of you quickly draw this diagram. All of you quickly draw this diagram. Single acting plunger or ram type. Hurry up. What are your that jack or the cylinder lift to lift? You are using a jack, no? So okay, I will show one video also. Okay, just to wait.
आज हवा ने एक नया अपडेट दिया.
Winter is here. हम हटेंगे पर्दे.
Quickly, I will show the video.
हेलो दोस्तों, मैं हाजिर हूँ एक नए वीडियो के साथ में। हम अपने इस वीडियो में बात करेंगे बेसिक हाइड्रोलिक सिलेंडर रैम सिलेंडर के बारे में कि किस तरीके से वर्क करता है, इसका कंस्ट्रक्शन किस तरीके का होता है और साथ ही साथ हम इसका यूज़ कहाँ पे करते हैं। तो दोस्तों मैंने यहाँ पे कुछ थ्योरी के पार्ट्स दे रखे हैं, आप चाहे तो इसको पढ़ सकते हैं जिससे कि आपको अच्छी तरीके से समझ में आएगा। मैं आता हूँ सीधे डायग्राम पे। दोस्तों सबसे पहले अगर मैं बात करूं कि रैम सिलेंडर कहते किसको हैं, तो जैसा कि आप यहाँ पे देख रहे हैं, व्हेन पिस्टन इज लार्जर एंड ऑलमोस्ट इक्वल टू द पिस्टन रॉड, व्हेन piston is larger and almost equal to the piston rod, it is known as ram cylinder. अब अगर मैं इसके कंस्ट्रक्शन की बात करूँ तो इसमें एक सिलेंडर होता है, जिसके अंदर रैम जो है वो इसके अंदर रैम जो है वो माउंट किया गया होता है। साथ ही साथ रैम के ऊपर जो है एक प्लेटफॉर्म प्रोवाइड किया गया होता है, जो कि लोड या फिर कोई भी ऑब्जेक्ट जो है उसको क्या करता है कि वो अप डाउन या फिर जिस वर्किंग के लिए हम यूज़ करते हैं उस चीज़ में ये फिर हेल्प करता है, उस चीज़ को उठाने के लिए अब अगर मैं इसके वर्किंग की बात करूँ कि ये किस तरीके से वर्क करता है, तो जैसा कि आप यहाँ पे देख रहे हैं ये इसका बेसिक पोजीशन है। व्हेन प्रेशराइज ऑयल एंटर थ्रू इनलेट, जैसे कि मैंने यहाँ पे दिखा रखा है ऑयल इन एक एरो के थ्रू, व्हेन प्रेशराइज ऑयल एंटर थ्रू इनलेट इट विल लिफ्ट द रैम इन द अपवर्ड डायरेक्शन, द लोड इज लिफ्टेड टू द रिक्वायर्ड हाइट। जब प्रेशराइज ऑयल जो है वो इनलेट पॉइंट से सिलेंडर में एंटर करता है तो ये रैम को अपवर्ड डायरेक्शन में लिफ्ट करता है। ये क्या करता है कि कब तक लिफ्ट करेगा, जब तक कि लोड जो है अपने रिक्वायर्ड हाइट तक ना पहुंच जाए। उसके बाद क्या होगा कि जैसे कि मैं आपको एक बार दिखा दूं, जैसे कि आप यहाँ पे देख रहे हैं कि यहाँ पे क्या है कि ऑयल जैसे एंटर किया तो रैम जो है वो अपवर्ड डायरेक्शन में लिफ्ट हुआ, अपवर्ड डायरेक्शन में मूव किया। ये तब तक मूव करेगा जब तक कि लोड जो है अपने रिक्वायर्ड हाइट तक ना पहुंच जाए। उसके बाद क्या होगा कि व्हेन ऑयल सप्लाई इज कट ऑफ to lower the load, the ramp comes down due to gravity force and oil is drained to the tank through the outlet port. मैं आपको एक बार फिर से बता देता हूँ कि when oil supply is cut off, जब oil supply जो है वो cut off हो जाएगी, to lower the load the ramp come down due to gravity force and oil is drained to the tank through the आउटलेट पोर्ट। मीन्स जब एक बार वर्क आपका कंप्लीट हो जाता है तो ऑयल सप्लाई जो है वो बंद हो जाती है और ग्रेविटी के कारण रैम जो है वो डाउनवर्ड डायरेक्शन मूव करता है और ऑयल जो है वो दोबारा टैंक में चला जाता है। मैं आपको एक बार फिर से दिखा देता हूँ, ये कुछ इसका बेसिक पोजीशन है और ये उसका जब ऑयल जो है वो सिलेंडर के अंदर फीड हो जाएगा तो ये तो रैम जो है वो अपवर्ड डायरेक्शन में मूव करेगा। ये अपवर्ड डायरेक्शन कब तक मूव करता है, जब तक कि जो लोड है वो अपने रिक्वायर्ड हाइट तक ना पहुंच जाए। दोस्तों अगर मैं इसके सिंबल की बात करूँ कि इसका सिंबल किस तरीके से बनता है, तो कुछ इस तरीके से हम इसका रैम सिलेंडर का सिंबल बनाते हैं। और साथ ही साथ अगर मैं इसकी बात करूँ कि ये इसका हम यूज़ कहाँ पे करते हैं, तो इसका यूज़ जो है एज अ लिफ्ट इन ऑटोमोबाइल सर्विस स्टेशन में करते हैं। साथ ही साथ मटेरियल हैंडलिंग के लिए भी हम इसका यूज़ करते हैं कि जैसे कि मटेरियल हमें मान लीजिए कहीं डाउन से अपवर्ड पहुंचाना हो तो वहाँ पे हम रैम सिलेंडर का यूज़ करते हैं। तो दोस्तों आई होप
So again, this is another example of a single acting cylinder, and we know it's a single acting cylinder because it only has one work port. Now we know it's a ram type cylinder because the rod itself is also the piston. And so this seal right here is the
This is a actual example of the ram type cylinder. Okay.
O-ring seal, and sometimes you'll see them with an O-ring seal and a plastic backing ring, and that backing ring would be on this side to prevent that O-ring from being pushed past this small groove here. High pressure oil has an amazing way of just slicing apart O-rings. And then we see again another dust type seal to prevent any contamination from getting into the cylinder. The simple operation of this cylinder is that we send hydraulic oil into its work port. It creates enough force by pressure being built underneath the surface area of the rod, and the entire rod acts as the piston and is able to travel until the O-ring snaps or bumps against the housing. To retract then, all it is that this oil is directed back to tank through the directional control valve, and gravity or the load is able to retract the ram. This is a very simple, cost-efficient cylinder. It just has some limitations in its ability that it doesn't have any pulling force, and it has some limitations in its overall force generation due to the pressure limits of having such a very simple seal and not a really high pressure seal there. Some of you will see these type of ram type seals or ram cylinders used on portable presses, and they still are able to create quite a large amount of force because they use a high pressure seal in there. To service these, you actually get into the back side right there, and you can see that the snap ring is accessible right there. You can see the end of the snap ring is just accessible. I'll just turn it so you can see the end of the snap ring. And what you can actually do is get on it with a seal pick.
All of you, please draw the diagram. Okay, I think you got the very well construction of this, how this single acting plunger or the ram type cylinder works. Okay, please draw the construction diagram, and then draw this symbol also. I have shown on the screen. Whether you understood or not, just tell me in a please write on your comment whether you understood or not construction about the single acting cylinder, single acting plunger or ram type cylinder. Okay, and please draw this diagram quickly so that we'll go for next type. Whatever the hatched line that shown, no, here this, that is cylinder you are. Okay, this is cylinder. That is ram. Please just look at mouse. Okay, then drain. It's the total, and this upper part is the platform or the you can call it as a load. Okay. Okay, due to the gravity force, okay, when your fluid intake will stop, no, that means is when fluid intake will cut off. That time, due to the gravitational force, okay, which will created by that due to the dead weight of the ram, due to that only your ram will come downward direction. And when ram will come in downward direction, that time your fluid will go outside through this drain. Getting it? That we have seen in the one example also. Okay, actual we have seen one animation video we have seen and one actual video. Okay. What? Now let us go for the next type. Okay, so next type of the hydraulic cylinder is the single acting cylinder with single rod piston, single piston rod. Okay, see, first we have seen this single acting plunger or ram type cylinder. Okay, single acting ram type cylinder we have seen. Now we'll go for the single acting cylinder with single piston rod. Okay, single acting cylinder with single piston rod. Getting it? So with the help of this diagram, I will explain you. Okay. So this single acting cylinder with single piston rod is I have shown in this schematic diagram. Okay. Now normally this single acting cylinder with single piston rod, this type of hydraulic cylinder is used for comparatively for low loads. Okay, application. Okay, low load application is what, as compared to the plunger or ram type hydraulic cylinder, as compared to that, wherever lower loads are there, no. So for that purpose, you can use single acting cylinder with single piston rod. Okay, and this cylinder may be gravitational return, gravity return, or spring return. Okay, that means what are the return action happening now? Whatever return action is going to happen now, so that will happen maybe due to the gravity or due to the spring. Okay, so whatever I have shown the diagram, it is a cylinder, okay, with spring return. Okay, so this cylinder finds its application mostly in the production tooling. Okay, in the production is what, for clamping, pushing, for that production application order. Okay, so it is also used in automation plant. Okay, in the automation plant also it is used where several cylinders perform individual operation in a predetermined sequence. Okay, in the automation plant where several cylinders perform individual operation in a predetermined sequence. For that purpose, this single acting cylinder with single piston rod is used. Okay, now how it works? Okay, how it works, that is a main important part. So look at it on the screen. Okay, this is what are the adjacent lines are there, no? Inclined line. That is your cylinder. Getting it? And you can see the port is one port is there. Through this port, you can take oil or your fluid inside. Then it will come inside this cylinder, and due to the pressurized oil or the pressurized fluid, it will apply the force on this piston. This is what are the piston? You can see out of this surface is there, no? It is called the piston, and this is a rod. So this is a single piston rod. Single piston rod. So when pressurized fluid will apply force on this surface, that time this piston will move in the upward direction, okay, toward this cylinder, okay, toward this cylinder head, okay. And when this fluid which is coming through this port, or when it cut off, that time due to the spring, this piston rod, it will come in the downward direction. Okay, that means what are the retention is there, no? That action will be happen due to this spring only. Okay, if you remove this spring, then due to the dead weight of this piston rod, due to that piston weight of the dead weight of the piston rod, due to the gravity, it will come in downward direction. And when it is coming in to the downward direction, that time what is the fluid which is available, which is available in the cylinder now, so that will go outside through this same port. Okay, so due to that only you can see the direction of that port. It is a bidirectional. You can take inside fluid through that port, as well as you can take out that fluid through that same port. Okay, so this is a single acting cylinder with single piston rod, and it is a spring loaded single acting cylinder, spring loaded cylinder. Okay, getting it? And it's a standard symbol. You can see cylinder is there. Okay, that is a rectangle. That aim is your inlet outlet port. Then this, okay, this is a piston, and this is a piston rod, and for retention this spring is used. Due to that only this triangular line it is shown. That is a standard ISO symbol for the single acting cylinder with spring loaded, okay, with single piston rod. Getting it? Getting it? Single acting cylinder. Quickly I will show video also so that you will get the, it's a construction. Okay, wait.
The purpose of a fluid system is to transmit power from one location to another. Fluid power is converted to mechanical power by means of an actuator. Cylinder actuators deliver a linear push-pull motion via a rod and piston within a cylindrical tube. A single-acting cylinder is a cylinder in which the working fluid acts on only one side of the piston. The other side of the cylinder utilizes a mechanical load, springs, compressed air, other cylinders, or the momentum of a flywheel to push the piston back in the other direction.
Okay, you can see on the screen.
This particular cylinder utilizes a spring on the non-fluid side. A single-acting cylinder produces linear motion in one direction. When a control valve directs fluid through the inlet port into the blind end, pressure builds up and generates a force on the piston. When the pressure buildup is large enough, the piston begins to move, extending the rod. This is called the forward stroke. When a control valve directs fluid out of the port, the fluid pressure is removed. The force of the spring pushes against the piston in the other direction, and the rod returns to the cylinder. This is called the retraction stroke. Single-acting cylinders are most often found in reciprocating engines, pumps, and hydraulic rams. A double-acting cylinder is a cylinder in which fluid acts on both sides of the piston. This type of cylinder can produce linear motion in two directions. A double-acting cylinder has two fluid ports, one on the blind end and one on the rod end. A directional control valve sends fluid through the blind end port while venting fluid out the rod end port back to the tank. Pressure builds up and generates a force on the piston, causing the extension stroke. When the directional control valve is shifted, it sends fluid into the rod end port, out of the blind end port, and back to the tank. Pressure builds up and generates a force on the other side of the piston, causing the retraction stroke. To determine the speed of a piston during extension and retraction, we must first determine the significant working areas. The full piston area is the side of the piston. The significant working area is called the
Okay. Okay, I think you got the idea about this single acting cylinder. So now all of you please draw this diagram. Be fast, please draw this diagram. This is a single acting hydraulic cylinder with single piston rod and it is spring loaded. Okay, and please see that it's a symbol also. I will show another video also, plus, but before that, please draw this diagram. Hurry up. Be fast.
In this video, I explain what is
Over. Now let us go for another video about this single acting cylinder. Okay. I will show. Okay, wait 1 minute.
Acting and double acting hydraulic cylinder. In this video, single acting and double acting hydraulic cylinder. In this video, we will explain the difference between a single acting hydraulic cylinder and a double acting hydraulic cylinder. A single acting cylinder has a piston rod, a cylinder barrel, a hydraulic seal, and normally a bearing to limit how far it pumps out. When you feed oil or your hydraulic fluid into it through the inlet port, it will extend, exerting a force, in this case, lifting a mass. In this example, we're using a micropack hand pump to provide the pressurized fluid. Hand pumps are low-tech and easy, but you could alternatively use an electric pump or air-driven pump. When it has done its work, you need to release the fluid back into the tank. To do this, we fitted a needle valve into the micropack hand pump. You open the valve and the oil flows, letting the mass drop. You always need a way of returning the cylinder, either gravity return or use a spring. So the single acting cylinder will pump out, doing its work, and retract when the fluid is released back into the tank, in and out. A double acting cylinder will allow you to push and pull under hydraulic power. You've got a smaller piston rod with a seal on a piston. You have a cylinder barrel and a piston rod bearing with an extra seal. This forms a second hydraulic chamber. You'll need a 4-way directional control valve to operate your double-acting cylinder. We've added one to our micropack hand pump. There are 2 connections on this valve, one at either end of the cylinder. Pressurize the bottom of the ram or full bore end to generate force. You need to connect the upper chamber or reduced bore to the tank, or the ram will jam. You can see the ram is now extending. At the end of the stroke, we are reversing the 4-way valve, so the pressure feed is now connected to the reduced bore end. We can now retract the ram under power and pull the rod back. It doesn't need a spring or gravity to return it. The force generated by the hydraulics will be smaller because the area is smaller. Now you've seen single and double acting hydraulic cylinders or hydraulic rams.
Please look at on the screen. See what is the difference between single acting and double acting cylinder. Okay, double acting yet we have not started, but just concentrate on the single acting cylinder. Okay.
In action. A simpler single-acting cylinder that needs gravity return, and the more complex double-acting ram that provides force in both directions. At Serum Hydraulics, we supply micropack manual pumps to operate single and double-acting cylinders. And as the hand pump experts, we...
Okay, so this is about today's lecture. We have covered the first hydraulic cylinder, that is the single acting cylinder. In the next tomorrow's lecture, we'll start with the double acting cylinder. I hope you got the today's point. Okay, because after explanation with the help of the schematic diagram, we have gone through the for animation videos. Okay, okay, with respect to each and every point we have seen the. Okay, so whether this method is understandable for you all. Okay, just tell me after each point. Do you want to any? Okay, yes. Shubham saying yes. Okay, so hereafter I will follow this method so that it will be very easy to understand you all. Okay, after each and every point, each and every type of the cylinder or of the motor, I will show some videos related to that point so that it's a construction working each and every part you will understand. So I request you all. Now, please write down your roll number in the chat box, and after writing your roll number in the chat box, you can leave this meeting. Thank you. Remaining students, please write down your roll number. Rohit Kadam, Sondakke, Rohit Jundre, Sambhaji Patil. Please write down your roll number and you can leave this meeting. Thank you. Sambhaji Patil, Rohit Kadam.